In this session, we're going to solve some questions to prepare for quiz 2. That's Math 1120. Okay, without wasting time, let's go to the first question. So these questions were picked randomly from various past papers, from previous years, including your current tutorial sheet 2 and tutorial sheet 3 for this year. Okay, so let's start with the first one. We are saying a man with 180 meters of fencing wishes to fence off a garden in the shape of a rectangle. What should be the dimensions of the area if the garden is to be as large as possible? Now, earlier today I received a question, sir, what topic is this one? So this topic is on functions. Okay, so now we're talking about application of functions. You've learned functions, but how do you apply them in real life problems? Okay, so with us here we have a man. So he wants to find the dimensions of the area so that he comes up with this fence of a garden. Okay, so what are we going to do? So I'm going to allow me to let the length of the rectangle be L. Okay, so I'll let the length be L. I'll let the length be L, and the width of this garden, I'll say it's W. Okay, so now let's find the perimeter and the area of this rectangle. So now you remember that perimeter is just the total surface area of a shape. Okay, the total. So let's say this is our rectangle. Okay, so since perimeter is the total, so if I say this is L, this is L, this is W, and this is W, perimeter, it means you're going to add all of them. So our perimeter will just be equals to you're going to say L plus L, that is just 2L, plus width, that will just be 2W. Okay, so now they're saying a man with a 180 meters of fencing wishes to fence off a garden. So he already has a fence of 180 meters. Okay, now he just wants to fence this garden. So the perimeter, therefore, it is 180. Okay, so we're going to say 2L plus 2W is equals to 180. Okay, that's the total surface area. So now what do? We can divide throughout by half, so that we're going to remain with L plus W is equals to the half of 180, that is just a 90. Okay, and that is our perimeter. Now how do we find the area? You know that your area is just multiplying your length times your width, right? Okay, now from the first equation that we got, if we make width the subject of the formula, so it will be width is equals to 90 minus L. Then we found our area to be area is equals to L times W. Okay, so we can say our area is equals to L multiply the W. We are saying it is 90 minus L. Okay, so where there is W, we're going to replace 90 minus L. Okay, so then we solve. We distribute the L, so we're going to have 90L minus L squared. Okay, or just write it in standard form, it will be 90L minus L squared. Or if you want, you might also want to bring it becomes negative L squared, but even like this is just fine. Okay, now the equation area is equals to 90 minus L squared. It is a quadratic expression. Okay, so you're able to see that the value of our A is negative. Hence, this is a parabola that just opens downwards. Okay, downwards. So it will mean that since it opens downwards, the maximum area will happen at a certain point, right? Because it's a quadratic, right? A quadratic can either have a minimum or a maximum. Okay, so now there is a point. So this point will be the maximum point, this point will be the minimum point. Okay, so now if it is going to have a maximum point, it means that that's the highest area that you can have at that point. Okay, all these other areas that will be coming down, they'll be less than the highest point, which is the maximum. So in this case, at that point is called the what? It's called the turning point. Okay, so the maximum area is at the turning point. Okay, so we have to find the coordinates of the turning point. So how do we find the the turning point? So how do we find the coordinates of the turning point? So you know that if you're finding x, or in this case let's say L will just be equals to negative b over 2a. That's the value of x at that point, so it's negative. The value of a is just the value of b. The value of b is what? It's a 90, right? Okay, 90. Oh yeah, it's 90 over 2. Our a, what is our a? Our a is negative 1. So you solve, you've got negative 90 divided by negative 2. Oh, negative 90 divided by negative 2. That just gives us a 45 meters. Okay, and that is the value of L at that point, or the value of x at that point. Let's find the value of y, or w. W, we've said, you remember we wrote this equation, w is equals to 90 minus L. Okay, so we're going to say w is equals to 90 minus our L. We found that it's 45. Okay, so 90 minus 45, that is just a 45. Okay, so we found L and the length. We found the length and the width. So now what will now be the question is, what should be the dimensions of the area if the garden is to be as large as possible? So you know that the area is the one that gives you the dimensions which are as large as possible. So therefore the area is just equals to the length times width. We found our length to be 45. This will multiply by 45. Okay, when I punch this on my calculator, I get 2025 okay, it's meter or square meters, like that. So this will be the maximum area that you're going to have. This is from Math Tutorial Sheet 2 2025. Okay, then this is from Math Tutorial Sheet 3 2025. Okay, so there was a question given the equation that where x represent the number of items sold, describe the profit function for a certain business. How many items should be sold to maximize the profit? Okay, so in as much as functions can be used to find areas in construction, functions can also be used in the world of business. Functions can also be used in the world of economics. Okay, so we're still talking about the application of functions. Okay, so again, it's the same principle. How many items can be sold to maximize the profit? Because you're talking about the maximum, you're just finding the turning point. Okay, so x will just be equals to negative b over 2a, okay, which will be equals to negative. Our b in that regard is it 180? Yes, over 2. Our a is negative 2. Then you're going to say 180 divided by, 2 multiplied by negative, okay, negative 2 multiplied by negative 2, that is just a negative 4. Then 180 divided by negative 1, okay, the negative and the negative will cancel. So 180 divided by 4, what do I have? 4 into 18, that is like a 4, remainder 20. 4 into 20, that is 5. So for us to, for this business to maximize their, their profit, it means that the business should sell 45 items to maximize the profit. So that's how you apply functions in the world of business. Okay, so let's proceed. Now, I've included this equation because it's very important. I'm sure maybe it's one of those high yield. Okay, you can't afford to go into that quiz without knowing the concept of completing the square. So I'm saying express each of the following quadratic expressions or functions in the form that, where that, okay, so these are the quadratic expressions. So I'm just going to solve the first one. Okay, the other ones you can still go through, because these are just revisions. Okay, so we want it to be in the form of a x plus p squared plus q. Okay, then we also thought to find the turning point, to sketch the graph, and all those kind of things. Okay, so let's start with the first one. We are saying f of x is equals to 2x squared plus 8x minus 3. So now what do? We factor out 2. Okay, so there are two methods. I'm going to go with the method that I taught you guys. Okay, so I'm just going to factor out this first two. Then I'm going to leave out this. I'm going to be going with this one until to the end. Okay, so when I factor out 2, I'll have 2, okay, x squared plus then our 4x minus 3. Then I'm going to find the half of 4. The half of 4, so 4 multiplied by half, that is just 4 over 2. 4 over 2, that is just a 2. So therefore the half of 4 is 2. So now what I'm going to do is I'm going to write the 2, that's the way it is. Okay, then I have x squared plus 4x. Then I'm going to square, so I'm going to say plus 2 squared. Then I'm going to also minus 2 squared minus, remember, don't forget your minus 3 outside. Now what I've just done here should take us back to the previous expression. Okay, that's why we're subtracting. So we're going to have 2. Then what I'm going to do, I'm going to ignore this 4x, the one that we've halved. Then I'm going to put those ones with the squares in the same bracket. Okay, so let me just do that. So I'm going to have x plus 2, this is squared, then minus 2 squared, it will give me a 4. So I'll have a 4. Okay, then there's a minus. Don't forget your minus 3 outside. Then I'm going to now distribute the 2. Okay, when I distribute the 2, I'm going to have 2 x plus 2, this is squared, minus 2 multiplied by 4, that is like 8. Okay, minus 3. Therefore now our final answer will now be 2 x plus 2 squared negative 8 negative 3, that just gives me a negative 11. Okay, so this is our final answer. Then how do we graph this expression? Okay, so very straightforward. So just to be quick, let's say these are axes says, okay. So we also have to find, you know, where if it's going to cut the x-axis, the y-axis. So for us to find where it's going to cut the y-axis, just wherever there's x, put 0. So if it's 0, there's 0 here, you're just going to remain with a -3. Okay, so our -3, let's say our -3 is here. Okay, that's one of the point where to cut the y-axis. Then you also have to find the turning point. The turning point is just you know, the turning point is just equals to -p comma q. Okay, if you've solved like that, if you want, you can say x is equals to -b, you know, over 2a. But we already have an equation that we've solved, so it's even easier. You're just getting the values. So your -p is the value of x. So in this regard, since it's 2, in that regard, it would be -2. That would be the value of x at the turning point. The value of y at the turning point would be that -11. Okay, so we have -11. So that is our point at -2, 11. So let me say this is my -2. Okay, then let me say -11 is somewhere there. So that is the turning point. Okay, so now how is our graph going to be? So our graph is going to start from here. It's going like that, passes through this turning point, and it passes through this point, okay, the y-intercept. Then it also cuts the x-axis. Therefore now we have to find these two values that are here, okay, where it has cut the x-axis. So I'm going to get the same equation that I just simplified. So I'm going to have 2x plus 2 squared minus 11 is equals to 0, because you know what, on the y-axis y is equals to 0. Then you solve for x. So what I'm going to do is I'm going to say 2x plus 2, this is squared, is equals to, I'm going to take the -11 to the other side, and it will become positive. Then I'm going to divide by 2 on both sides. Okay, when I divide by 2 on both sides, for me to remain to you know, for me to cancel the, I'm going to square root on both sides for me to cancel the square, the square. Okay, so I'm going to square root on both sides. So the square and the root will cancel. So I have x plus 2 is equals to the square root of 11 over 2. Okay, then I'm going to take the 2 to the other side. So x will be equals to -2 positive or minus the square root of 11 over 2. So therefore these my points will be the first point will be negative minus, you know, 11 over 2, the square root of 11 over 2. This one would be -2 positive the square root of 11 over 2. I'm done for that one, and that's how we do for the rest of these ones. Okay, very, very important for you to understand and to know. Then the other thing that I should make clear is when your a is greater than 0, okay, and when your a is less than 0, what are the conditions? What are you supposed to know? Okay, when your a is greater than 0, it will be a minimum. Okay, a minimum, like this graph that we have, it has a minimum turning point. But when your a is less than 0, okay, when your a is less than 0, let's say negative, it will have a maximum turning point. Okay, so you must know those ones as well. Now let's proceed. Question number 7 is about you determining whether the given function below are even, odd, or neither nor odd. Okay, so we've been talking about this several times, so I'll not also take it lightly. So we're going to say, well, let's solve the first one. So f of x is equals to 3x squared minus 4. Earlier when we were talking about, you know, even, odd, and neither functions, we said even before you solve, you're able to determine if it's even. Look at the powers of x and look at the powers, just the powers of x. The powers of x, they're able to tell you whether it's even or odd or neither. Okay, so you're able to see that this we can also put x, right, to the power 0. X to the power 0, that is just a 1. Okay, if in the 4 multiplied by 1 is to be a 4. So you're able to see that the powers of x in this expression, there's 2 and 0. 2 and 0 are even numbers. Even numbers are those numbers that are divisible by 2. Okay, now you're asking me, is 0 divisible by 2? Yes. If you say 0 divided by 2, it will give you what? A 0. Okay, but if you say 2 divided by 2, it will give you a 1. So there's no remainder that is there. Okay, so 0 is divisible by 2, even 2 is divisible by 2. Okay, so this will be an even function, but you have to solve. You just don't like that. You have to solve to prove. For an even function, we say f of negative x should be equals to f of x. Now we explained how this expression comes about, because you find that the value of y is unchanged at that point. We said if this is our graph, if you're going to do with a quadrant, let's say this is -1. Okay, let me say this is -3 and this is 3. The square root of 3 on this point to just give me 9, right? The square root of 3 also decided to give me a point 9. Okay, then 0, 0 to just be here, and if I'm to join this point, it just be like that. Okay, so therefore the graph of an even function is just x squared. Okay, f of x is equals to x squared, because this is a quadratic. So you're able to see that at this point this is -3, 9. On the other side this is 3, 9 still. So you're able to see that the value of y, yes, is changing. Okay, but the value of x is changing, but the value of y is not changing. This side is 9 and the other side it is 9. So what is happening is what? It has just been reflected to the other side. Okay, so that's what you should also remember. So if we're going to solve this, that's how this equation comes about. Okay, so if we're going to solve this, what are we going to have? So we're going to say f of negative x, wherever there is x, I'm going to replacing negative x. Okay, so I'm going to say 3 negative x, this is squared minus 4. Okay, so when I solve, f of negative x will just be equals to 3 negative x squared, that is just x squared minus 4. Now you're able to see that this expression 3x squared, it is the same as the question itself, f of x. Okay, now because your f of negative x, which is this one, it is giving you this, and this is f of x. It is the same as f of x. So this is an even function. Okay, so that's how you solve these ones. Okay, then the common one that they can give you, let me solve the f one. That's those are the ones they like bringing kuma quizzes to see if you understood the concepts. Okay, to see if you understood the concept. So we are saying f of x is equals to x squared plus 3 over x. So what are you going to do? You're going to say f of negative x is equals to wherever there is x, I'm going to replace it by negative x. Okay, so negative x, this is squared, plus 3 over negative x. So what am I going to have? I'm going to have negative x squared, that is just x squared, plus 3 over negative x. Now you're able to see that I have a negative down. Okay, so this is not, okay, it is not an even function. So now what do? We just have to factor out the negative. Okay, we factor out the negative, then we solve. So what is this? Because this will just be x squared minus 3 over x. This is not equals to that. Okay, so we are going to say it is not even. Now that you found that it is not even, check if it is odd, or so that you also determine if it's neither. Okay, one clue that I gave you earlier, look at the powers of x. This has a power of 2. Okay, this has a power of 1. Now 2 is an even number, 1 is an odd number. So therefore, because you have a combination, this is neither even nor odd. Okay, so you don't have to stress yourself like that. So that's what I'm talking about. So if let's try if it's odd. So if it's odd, we say it is f of f of negative x is equals to negative f of x. Okay, that's the expression that we should get. However, if we get this expression, x squared minus 3 over x, if we factorize it, what are we going to have? Okay, we're going to say, if we factorize this one, if we say let's factorize the negative so that at least it comes close to this one. But if we factorize the negative, we're going to realize that we're supposed to put negative x squared here, right? Okay, plus 3 over x. So it still won't work. Okay, so it won't work. So this is neither odd nor even. Okay, so that's what I'm talking about. Then question number 4 is find the range of each of the following functions. Now, the range and the domain, we've been talking about these ones, and I've put this question because they'll test you. Okay, they would want to know if you still know the range and the domain, because your quiz one was just sets. So expect you to find domains and the ranges. So you have to know all of them. For a linear function, you have to know. For a quadratic, you have to know. For a radical, a rational, a modulus, you have to know all of them for it to be safe. Okay, so our first question is f of x is equals to x squared plus 7. Now this is a linear function. What did we say the domain is for a linear function? For a linear function, the domain, everything exists. So this is from negative infinity to positive infinity if you are using set interval notation, or if you're just using set beta notation, you're just going to say x is a member of all real numbers. Okay, real numbers is any number you can think about right now in your head. A 0 point chan, all the numbers will be included, and this is a straight line. Okay, if I'm going to draw the diagram like that, this a straight line that we're talking about is linear because it just be going in a straight line. Okay, on a straight line everything exists, but if you say it is dotted, not everything exists, right? But on a straight line everything exists. Okay, that's what I'm talking about. So the domain, everything will exist. What about the range? Okay, the range, everything will also exist. Okay, everything will also exist. So y will be a member of real numbers. Okay, because every x value will have some y value on a line. Every x value will have some y value. So the range will just be all real numbers. Okay, which other one? Which other one? Okay, actually this is not a linear function, it's a quadratic. Apologies for that one. Okay, this is a quadratic. This is x squared plus 7. Okay, so the range now will somehow change, because for you to find the range you have to find the value of y. Okay, so where there's you solve the quadratic. Okay, you solve the quadratic and you find the values of x. So what you are going to do is, where there's f of x, you're going to replace y. So you're going to say y is equals to x squared plus 7. Okay, then you make x subject to the formula. Okay, so when you make x subject, it will be y minus 7 is equals to x squared. Then you divide, or you square root on both sides. So you're going to realize that your x will just be equals to the square root of y minus 7. Now the answer that you've gotten is the one that you now equate to 0, because you don't want a negative number in a root. So what do you want? So you're going to say your y minus 7, this should be greater than or equal to 0. You can have 0, yes, the square root of 0 is still 0. But if you have any number that is negative, so it will make the function and the function undefined. Okay, so you want values that are greater than or equal to 0. Okay, so therefore your y should be greater than or equal to, when you take the 7 to the other side, it will be negative 7. Okay, so you want all values that are greater than or equal to negative 7. Okay, so that's what we're talking about. So that's how you're going to approach this one. So that would be your range. So that's what you're going to do for all of them. This is a rational function. We've talked about how you find the domain and the range of a rational function. This one is also a rational function. These are still quadratic expressions. Okay, so you do well to also watch those videos. Okay, let's come to the second question. The roots of an equation that are alpha and beta. Find the value of alpha, 1 over alpha plus 1 over beta. Okay, I'm not going to solve all of them. There are videos, we've done everything, but this is just a revision. We're saying the roots of the equation are that, okay, and alpha and beta. We're supposed to find the roots. So you know that your alpha plus beta, and we said how you find these ones. The roots are just the answers, the two answers that you get after solving a quadratic expression. Okay, so what are we going to do? We say the roots is alpha plus beta is just negative b over a. Then if you're finding alpha plus beta, alpha multiplied by beta is just c over a. So let's solve this one. Alpha negative b. What is our b in that regard? Our b is negative 4 divided by our a is 2. Okay, so therefore what would be our alpha plus beta? Our alpha plus beta will just be negative 2. What about our alpha beta? Our c in that regard, what is our c? Our c is 5. Our a, what is our a? Our a is 2. Okay, so now we found our answers to be negative 2 and 5 over 2. So those are the the roots. So now we have to find, we've been now given specific roots. We've been given a we're saying is a over alpha plus b plus 1 over beta, like that. Okay, so how do you solve this one? Find the common denominator. The common denominator is alpha beta. So when I divide alpha into alpha beta, I'm going to remain with beta. Beta multiplied by what is on top, which is 1. So I'm going to have beta here, plus when I divide my beta into this, I'm going to remain with alpha. Alpha multiplied by what is on top, I'm going to have alpha. Okay, now addition is commutative, so I can swap the ones that are on top. Beta plus alpha is just the same as alpha plus beta. Okay, because addition is commutative. Okay, you remember those concepts. So now we got this expression. So what do? We just replace what we found. We found that alpha plus beta, we found that it is negative 2. Okay, so we're going to say this is negative 2. This is divided by alpha beta. Our alpha beta is, this is dividing by alpha beta, which is 5 over 2. So what I'm going to say negative 2. I'm going to change the sign. I'm going to say times 2 over 5. When you're dividing, the symbol changes and you swap the numbers. So you're going to have negative 4 over 5. So that will be our final answer. Okay. Then we have C. Okay, for C we are saying alpha squared plus beta squared is equals to what now? So what are we going to do? So this is just an identity. We say when you have alpha squared plus beta squared, it's just the same as alpha plus beta. This is squared minus 2 alpha beta. Okay, when you know that identity, you are good. Okay, so what you're going to do is, and we solve how you come up with this one in case you forget. So you expand this one. When you expand this one, then you take this one to the other side, you're going to realize that you are going to remain with this one on this other side. Okay, so that's what you're going to do. But if you know this identity, you don't even have to do that. You know it clearly. So what you do now, alpha plus beta, we said it was -2. This is squared minus 2 alpha beta. We found that it was 5 over 2. Yeah, so now you solve -2 squared, that is just a 4, then minus the 2 and the 2 can cancel, so you have 5. 4 minus 5, that is just a -1. So that is the answer that you're going to get. So here, what I want you to know is the identities. The identities will solve you a lot, because they'll ask you to even find equations. If the roots of that, write down an equation. So what you do is, the equation, okay, let me just write something very vital here. So the formulas that you should know here, the general equation is, you're going to say x squared minus the sum of the roots, okay, x plus the product of the roots. This is equals to 0. You have to know this equation. And last time we showed that we come up with this equation. Everything is there. Everything is there on the drive. You don't have to worry. You can still watch some of the videos. Okay. Then another equation that is very, very key on this topic is alpha plus beta. You have to know this one, okay? Because this will help you to find the answers, okay? So alpha plus beta, we said it is just negative beta over negative b over a. Then you also have to know alpha beta. Because this is a sum, which is that. Then this is a product, which is that. So you have to know these ones, okay? So alpha beta is just c over a, like we've shown. Then other equations that you need to understand is, most students tend to make a mistake where they say, because you've seen a question like C is alpha squared plus beta squared. Now because you are very in a hurry, you say this is just the same as alpha plus beta, then you square like that. Okay, this might be partially correct, but it's not fully correct. Okay, it is very wrong. So alpha squared plus beta squared, it is not equals to that. Okay, so don't make that mistake. Otherwise, the answer actually it should be, yes, the way that you've written, but just add a -2 alpha beta. You'll be correct like that. Okay, so you have to know that one. Another identity that you need to know is, what if we raise it to the power 3? So this is another identity that you need to know. So you're going to say alpha plus beta. Okay, this is going to multiply by alpha squared minus alpha beta, okay, plus beta squared, like that. You have to know this one, because it will save you like a lot of time. Then what if we raise it to the power 4? When it is raised to the power 4, what you're going to do, get the first expression that is on top, because this one you know it in your head. Then wherever there is a letter, just be squaring. So let me write the first expression just the way it is. minus 2 alpha beta. So what I'm going to do, wherever there is a letter, I'm going to be squaring. So alpha I'll square, beta I'll square, alpha I'll square, beta I'll square. So this will be this will be the identity for the one that has 4. So you know this one, you are good on this topic. Okay, when they tell you to find the roots of the equation, alpha, like this one, the alpha and beta, write down an equation which has roots and that. So what you are going to do, add these two. Okay, let me just solve this one quickly. So you add the 2 and you multiply the 2. Okay, then you are done. So what you do is find the sum first, the sum of the roots. They've already given you the roots. There's alpha plus 3 and beta plus, so you add plus beta plus 3 because you're adding the 2. So what you're going to do is you're going to have alpha plus beta plus 3 plus 3, that is a 6. So this will be your sum. Okay, then what will be your product? So you're going to multiply alpha plus 3, you're multiplying it by beta plus 3. Okay, so you have a beta plus 3. So you're going to multiply alpha multiplied by beta, that is alpha beta, plus 3 alpha. So you're going to say plus 3 alpha, plus, then you're going to have 3 beta plus a 9. Okay, then that is the expression that you're going to have. So what do we do? I'm going to say alpha beta plus 3. I'm going to factorize the 3 on, so I'll have alpha plus beta here plus a 9. Okay, now that I factorize, I have to now go in the original equation. I find out what is alpha beta and what is alpha beta. So what is alpha beta? Alpha plus beta, we said, is equals to negative b over a. So we're going to say negative. What is our b? Our b is negative 4. Okay, so let me say just positive 4 over a. Our a is just 1. So therefore our alpha beta is just 4. Then our alpha beta, when you're multiplying them, we said it is c over a. Our c in that regard is what? It's just a 2 divided by a, which is 1. So alpha beta is just 2. So what I'm going to do is I'm just going to be replacing these ones in the equations, okay, to find my answers. So like for this one, alpha beta, I said it is alpha plus beta is 4, okay, plus 6. So I'm going to get 10. Then for this other one, alpha plus beta, we've said it is alpha beta, when you're multiplying them, it is 2, okay, plus I've got a 3. Then when you add them, we said you're going to get we said it's 4, right? Yeah, 4 plus a 9. Then you solve like that. 3 multiplied by 4, that is a 12. Okay, a 12 plus 2, that is like a 14 plus 9. Okay, so when you add 14 plus 9, what do you get? Okay, so that is something like is it a 20 what, a 23 or something like that? Okay, so let's say 14 you add 6. Okay, that is like, yeah, 23. So these are the answers. So we find the sum to be 10 and the product to be 23. So what you're going to do, you're just going to write it in the standard form that you're supposed to do. So what do? You're going to say it should be x squared minus the sum we said is 10, right? X, okay, plus what is the product? 23. This will be the equation that they want. So you have to know that one. Very, very good. High yield as well. Okay, let's talk about polynomials. Finding the remainder, the quotient, all these kind of things. So polynomials, they have a power of 3 and go above. Okay, so no polynomials, videos are still there, just pass through. You can check both files. Okay, not just for math 1100, not just for 1120, just check for both of them. Okay, so that you gain even deeper insights, because most of the things are just the same. So what do? We're saying find the quotient and the remainder when that is divided by that. Okay, so if we're finding the quotient and the remainder, there are two formulas that you can use. You can either use long division or synthetic division. Okay, so the first one, I'm going to solve it using both. Okay, both synthetic and the remainder. So I'm going to say x plus 3. This is dividing it into x to the power 3 minus 3x squared plus 2x plus 7. Okay, using long division. So always divide with the highest power of x. In this case, it's just x. If it was squared, we're going to use x squared. But now this is just x. So we divide x into x to the power 3. So what are we going to have? We're going to have x squared. X squared is going to multiply with x. Again, it's going to multiply with 3. So let's just do that. So we're going to have x to the power 3. Then it multiplies with 3. It's just going to plus 3x squared. Okay. Then I'm going to subtract. So this minus that will just give me a 0. Okay. Then this minus that. Okay, what am I going to have? I'm going to have a negative 6x squared. Then I'm going to divide x. I'm going to divide it into this expression. So what am I going to have? I'm going to have negative 6x. Then I'm going to I'm going to multiply by negative 6x almost with this expression. So now what am I going to have? I'm going to have negative 6x squared. Then when I multiply it with the negative 3, with the positive 3, I'm going to have negative 18x. Okay, so this is my expression. Then I'm going to drop the 2x, so I'm going to say plus 2x. Then I subtract. Okay, so now what am I going to be doing? Just the same expression, negative 6x minus 6. That will just give me a 0. Okay, then I come to this one, 2x minus 18. Okay, so it means these ones will be adding, right? So this will just give me a 20x. Okay, then I can divide with the x again. When I divide with the x, I'm going to have a 20, so plus 20. Then 20 when I multiply by so I'm going to have 20x plus 20 multiplied by 3, that is like a 60. Okay, then I'm going to drop, allow me to drop it like that. This is plus, I'm going to drop the 7. Okay, then I subtract the expression. So this and this one will give me a 0, which I will not write. Then 7 minus 60. Okay, 7 minus 60, that will be like 50 what? Is it 53? 53. So now what you're able to see that the remainder, because your answer should be in the form of the function itself or the polynomial divided by what you are dividing by, the divisor, is equals to the remainder that you found. The remainder that we found, that, you have to first write the quotient. The quotient, x squared minus 6 x plus 20 plus the remainder that you found, which is 53, over what was your divisor x plus 3. It should be in that form. So that's how you solve this one using long division. Let me solve it using synthetic division. Okay, so I'm not going to solve all of them. That's why I'm just doing everything on the first one. Okay, so how do you do using synthetic division? We are saying this is being divided by x plus 3. So I'm going to say x is equals to negative 3 when I equate it to be equals to 0. So I'm going to say, since x is equals to negative 3, I'm going to draw this line. Okay, this line. Okay, so from my equation, our equation is x to the power 3 minus 3x squared plus 2x plus 7. Okay, so now what do you do? Get the coefficients of x. Make sure that the coefficients of x are decreasing. What do I mean? If they just give you, mostly in your quizzes, they will not write the way they've written it like this. They write maybe x, maybe let me say 2x to the power 3, yes, minus x plus maybe 7. This, if you follow this and you get the coefficients, you're only going to have 3 coefficients, right? 2, negative 1, and 7. If you write it like this will be wrong. Okay, this will be wrong. So what you are going to do is just imagine that there's an invisible x squared here in the middle. Okay, so when you're putting your answers, you're going to put 2, 0. Okay, then that's when you put negative 1 and 7. There will be 4 like that. So that's what I mean, that your powers of x should be decreasing, otherwise your answer will be wrong. So let's just do that. The coefficient of x here is 1, here it's negative 3, here is 2, then we have a constant 7. So here just put a 0, then add 1 plus 0, that is a 1. Then you multiply negative 3 and 1, the answer that you're going to get, you put it there. So let's just do that. So negative 3 plus that will just give me a negative 3. Then when I add the 2, I'm going to get a negative 6. Then negative 3 multiplied by negative 6, that is like a positive 18. Okay, then 2 plus 18, that is like a 20. A negative 3 multiplied by 20, that is a negative 60. 7 minus 60, that gives me like a negative 50, a negative 53, like that. Okay, so you're able to see that this will be a remainder. Then when you're writing your answer, the powers of x they've decreased by 1. So this was x to the power 3. Now because you've used synthetic division, the answer will be, they'll drop by 1. So you're going to have x squared minus 6x plus 20, which is the same as this one, our quotient. Okay, so that's how you solve using synthetic division. Okay, so this is where we're going to end for today, and I wish you well in your test, in your quiz actually. Good day.